The 73rd International Astronautical Congress is underway in Paris, once again bringing together thousands from the space industry to discuss the latest in space exploration and technology. Stay tuned as we'll be covering everything you need to know from this year's IAC. IAF Congress TV starts right now. Hello and welcome to the second episode of IAF Congress TV, where we'll be highlighting all the latest at this year's International Astronautical Congress. My name is Ru Abbas, and today we'll be looking at what the next generation of space exploration is going to look like. We'll take an exclusive look at what some of the leading industry organizations are working on and speaking to some of the leaders in the industry. So let's begin with the head of strategy and innovation at the Ariane Group. I'm now joined by Morena Bernardini. She is the head of strategy and innovation at the Ariane Group. Thank you very much for joining us.
Thank you for inviting me.
I'd like to start by asking you about how the launch service market looks and what are some of its challenges.
Linearspace, which is marketing our launches, Ariane 5 and later on Ariane 6, has confirmed the trends of mega constellation for the coming years. This is a big change compared to, let's say, the last decades with the successful double launch of Ariane 5. And you see also it's defining how strategic access to space is. And we, Ariane Group, we're arriving with a new launcher to be launched next year, who's actually perfectly fitting this, because Ariane 6 will be almost suitable for, I would say, all missions to orbit. According to the next challenges, of course, we have to go through the maiden flight and then be able to very quickly ramp up, because we need to serve this market. It is not harmless that Linearspace already sold 29 Ariane 6, which is quite unusual for a launcher that never flew.
And what would you list as some of the more recent accomplishments for the Ariane Group?
Well, first I would recall just the last launch in September. We put in orbit a very important telecommunications satellite. Then I love to recall the last Christmas Day with the launch of James Webb Telescope. That was amazing. And by the way, a NASA administrator came into our facilities to thank our team, because we could double the lifetime of the telescope thanks to the very high precision of the injection into orbit. And then I also would like to recall the combined test that we are now doing in French Guiana. It's the time the launcher is meeting his launch pad, and this is also a major milestone in the Ariane 6 roadmap.
And what role do you see the Ariane Group playing in future space exploration?
Well, we are the space enablers, so of course it is our duty and our pleasure to put objects in space. Yesterday we revealed a new project, SUSY, who's going to bring objects and humans into space. So we are very much engaged with our customers and with the research for the exploration in the future. And that's also why we proposed a new family of launches for the next generation of our launches, because you see, we have not flown yet Ariane 6, but we are still thinking 10 or 15 years onwards. SUSY is part of that, and SUSY, with the other launches of our family, will of course continue to enable the exploration in the coming decades.
Morena Bernardini, thank you very much for your time.
Thank you.
With the Congress well underway, we asked some of you for your views on the challenges that the space industry needs to address. Let's take a listen to what some of you had to say.
The first point of view I want to come from is the area of inclusivity. Currently, When you talk about the space industry, when people hear about outer space, they only think about science. I'm a lawyer, and I'm interested in space, and I'm interested in the policy part of space and the legal aspect of it. So the space industry needs to be broadened enough so that a lot of experts and professionals can be included in the space industry. Also, in the area of diversity, I would like to talk about inclusion of gender. The space industry is dominated by the male. When you bring in females and other people and people of color, so many ideas, so many perspectives will be brought into the industry.
In India, for example, we have a lot of engineers, we have lawyers and doctors, but nobody wants to go into the space sector because all they feel is that going into the space sector is like you just can't be an astronaut. Like there's not much maybe awareness about the space sector as you get, but it's definitely growing because there are a lot of startups with a dream and with the brain power to do it. So yeah, I mean, definitely that's a big challenge. So if we can raise the awareness and the funding for the space programs in countries such as India, definitely something that can be looked into.
We are looking in particular to the threats in space. We are looking on what we can do to limit, to reduce all the risk and the threats in this environment. I think the industry is directly linked to this challenge, which is to find the best solutions, the best orientations to fill up this problem, which is peace in space. That is the main challenge I see today.
To me, like the biggest issue for the upcoming generation is like debris removal, because we need to guarantee access to space by protecting space environments.
The space industry is changing, and we're moving to more and more new space, and we have an entire planet engaged in a way that has not been true before. So I think the challenge is, how do you make everybody in the world know what is out there and what the excitement is in terms of building spacecraft, in terms of doing science in space? And how do you actually make it available to everybody?
Space has long been synonymous with adventure, exploration, and discovery. We need to consider what space brings not just to the everyday lives of people on Earth, but also to the progress of science. So let's take a look at how space can help us live better on Earth.
Space for all is now very important, because space was for a long time devoted to small communities, principally science community, knowledge, and defense community. And all the agencies around the world are used to work with these two communities, which are quite small. And now space is more and more used for agriculture, fishery, mobility, land management, security, health, a lot of things. So it becomes more and more important for not only these small communities, but for the whole people around the world, everywhere. So it changed a lot of things, because with this new application, you make business. So it opened the door to investments and so on. It was very close and specific market before, and now these two pillars, science and defense, are important and maybe more and more important. But we have also this new development of space, which is for all. And what is mean space for all? One thing we are facing, of course, and it is very important, is climate change. It will change our life in future years. It already changed a lot of things. And the elements followed by scientists to understand how the planet evolves and how the climate change is measured by more than half, more than 50% is measured by satellites. So already satellites monitor the Earth and know what is changing and how to adapt. But in new exploration, we are returning to the Moon, then Mars, and then to make women and men living and working on the Moon, you need to build new bases, you need to tackle waste management, to tackle energy, to know how to deal with mobility around and between these bases. A lot of things which are used on Earth, and we will learn a lot. And already big firms in health, in waste management, in logistics, already working, big industries, nutrition, food, begin to be interested in that new area when they can go to space. We as space specialists are waiting for them, but also they can use that as a trampoline for future development, and which is very important for them. So space will more and more make the life on Earth better.
The fourth industrial revolution is currently underway, with machine learning and artificial intelligence technologies making significant advancements and changing industries. The next 30 years will revolutionize our efforts in space and on Earth. Let's take a closer look at how.
Looking ahead to what space exploration and technology is going to look like in the future, I think that if you think about the work we've done so far in space, most of it has been focused on exploration. Right? And the goal of exploration is really to do science, to further our understanding of the planets and the solar system. I think, driven by the fourth industrial revolution and how it relates to space, we're going to move from, or actually start doing, in addition to science, we'll start to do development. And what development is about is to start to establish an economy in space and to build infrastructure. So that's what I see the change, is that we're going to building infrastructure, building systems that can help us establish that in-space economy, like communications networks, power infrastructure, transportation infrastructure. That's where I see it going. What excites me the most about the future of space activity is technologies that can have and enable a step change in capability, where we're really changing something fundamental. There's a few areas that in particular, like quantum computing and more specifically quantum communications. So we're dealing with such vast distances in the solar system. Being able to communicate better and more securely across those distances is really a step change in capability. Second area would be artificial intelligence and autonomy. So if we can have our spacecraft be a higher degree of autonomy, it'll be safer for the human crews, but also we can do more and go further. And instead of sending back data to Earth, we can send back the answers to our questions, which I think is really exciting. And then finally, the ability to use nuclear power and propulsion in space is really a step change capability where we can generate large amounts of power and have propulsion systems that use fundamentally different technology to explore further.
Let's take an in-depth look at organizations currently paving the way in the space industry. First, we go to Leo Labs, where they provide services to the space industry for protecting assets in low Earth orbit by tracking satellites and dangerous space debris down to 2 centimeters in size.
So the industry is going through an inflection point that you rarely see. 3 years ago, there were 800 satellites operating in LEO. Now there are close to 4,000 satellites operating there. And in the next few years, it'll be close to 50,000 satellites. So the traffic's ramping up dramatically.
Launches are more frequent, and there's a underpinning of lack of regulatory rules. It's still sort of the wild, wild west out there. So what that means is, as companies are launching all these new satellites, they need infrastructure and services to ensure that their businesses are safe, their satellites are safe, and they're operating effectively and responsibly.
The problem that Leo Labs is solving is tracking and knowing where everything is in space that's orbiting the Earth, so that we can allow greater use of space, greater profits to be had in space by the various companies moving into space, and greater security in space.
Leo Labs is the only company that's pursuing the end-to-end solution. We start by generating the data, by running this worldwide network of radars located in the northern and the southern hemisphere. We then run many layers of software, so digital signal processing, orbit determination, conjunction alerting, and a whole set of AI ML tools, and that generates real-time information.
We have built and we operate a modern space infrastructure stack that consists of phased array radars on the ground, looking up into space, tracking thousands of objects in low Earth orbit every hour. So that includes live satellites that are maneuvering, dead satellites that have been up there for decades, old tumbling rocket bodies that have been around for a long time, and thousands of pieces of space junk.
Getting hit by something even this big is still really bad. Something, as small as 2 centimeters across. Because remember that those objects can be moving relative to you up to 14, 15 kilometers per second. So that's in the range of 35,000 miles per hour. So even getting hit by something as small as 2 centimeters across will totally ruin your day, and perhaps the day of your business or the year of your business.
If you have a primary object and a secondary object that are on risk of collision, we are running algorithms that would tell us where they might meet in space and at what time. And so with that, we create reports that we can then tell the customers, hey, here's what's happening. And they can actually take action to avoid, of course, a space collision or something like that happening.
We're layering on top of that decades of experience in space industry to be able to not only bring the community the best content through these radar measurements, but the best context, perspective of what does this data really mean for the immediate space safety, but also long-term space sustainability.
We have teams located around the world. We have a team in the US, we have a team in Australia, and a team in Japan. And every single day they are handing off operations between time zones so that we maintain a continuous watch over space.
Essentially, you can think of it as like a living map of space. The trajectories and coordinates of all the objects up there, the satellites, the debris, updating continuously every second throughout the day.
LEO Lab serves 60% of all the active satellites in low Earth orbit. We're putting out over 400 million conjunction data messages every single month, and we've supported the launch of over half of all the active satellites in LEO, locating those satellites within hours after they reach orbit to help the operators move them safely into full operations. LEO's going through a once-in-a-generation transformation. It used to be all about exploration and militaries. This new space race is all commercial. Commercial innovation is driving the large numbers of satellites, it's driving the new human space flight, and it's connecting space back down to the ground in a way that's never been seen before. We are rapidly expanding our radar network. We have 4 sites in operation today. We have 3 more sites under construction, and we're going to keep building after that. So we have radars located in the US, in Alaska and Texas, a radar site in New Zealand, in Costa Rica. We've got a construction site underway in the Azores, as well as West Australia and another undisclosed location.
Over the next few years, we plan quite a large number of new radars that will give us worldwide coverage of areas above the Earth, which is missing today. Among the other things that we've done that are really notable are that we've improved the sensitivity of our radar so that we can track smaller and smaller objects. Objects smaller than anybody else in the world is tracking. And we've built the systems that allow that data to be served up to customers so that they can be protected from these smaller objects, which are out there, but which nobody else is tracking. Having flown in space, I know that the greatest danger to astronauts in space in the long term is space debris. And we're the only company, the only organization that's actively working to reduce that risk in a meaningful manner. And that's because we're working to build the tracking network that will protect the astronauts from objects which are too small to be tracked by other networks.
As we build out our global network and we mature our discovery of small, lethal, non-trackable debris, what we're really going to be able to do is provide services that will enable better design, better manufacture, better deployment, better operations, and more reasonable retirement process, so that whole life cycle will really bring much more benefit to the industry than just keeping you safe for that one conjunction event.
When you see the ultimate outcome, which is, we're actually helping keep space safe, that is a reward that it's just hard to describe. It feels good to work here, and it feels good to work with a team that connect well with each other, because I feel like teamwork is what makes it a success. And I think that's a very strength of Leo Labs.
Next, let's learn about Thales Alenia Space, a global space manufacturer that combines over 40 years of experience in the design and delivery of high technology solutions for telecommunications, navigation, and Earth observation, along with environmental management, exploration, science, and orbital infrastructures. Governments, institutions, and companies rely on Thales Alenia Space to design, operate, and deliver the systems they need for the next generation of space and technology.
Space for Life means for us a new horizon for humankind to improve our knowledge of our environment, which includes the full universe, to build a better and sustainable life on Earth.
Space for Life, en fait, pour moi, c'est l'espace au service de la vie sur Terre, pour l'observer, mieux la connaître, la comprendre, pour mieux la préserver.
Space for Life, it's an ambition. It's a really huge field of technologies. On most of them we have progress and we already know what to do. On other cases we have still to work.
Thales Alenia Space is involved in all fields of space applications, starting from Earth observation to telecommunication, to navigation, to human spaceflight, to robotic exploration, to re-entry vehicle.
We are fully active in most of the future program for Mars. We are involved on most of the activities that are dealing with the return to the Moon.
Our environment is not only the Earth. Earth is very important, is where we live, but our environment is the universe. To contribute to the capability to explore, the capability to acquire new knowledge. That is really exciting. Thales Alenia Space is a big company. We are almost 9,000 employees, most of them between France and Italy. We are dealing with all the domain of space product.
We have more than 40 years of experience. We have worked for 15 years for the International Space Station. We are really working with most of the companies worldwide that are in the space business.
The agency rely a lot on us as a Thales Alenia Space in our commitment to get everything not only on schedule but also within the budget. We are always committed to support them and to provide them with every solution they need.
Alors l'observation de la Terre, c'est à des fins d'études, de connaissances pour la protéger et la préserver. Thales Alenia Space, c'est une part d'activité très importante dans le milieu spatial puisque ça représente 26% de nos activités. Alors la mission SWOT, c'est une mission scientifique. Alors SWOT, ça veut dire Surface Water and Ocean Topography. C'est un satellite de nouvelle génération qui va permettre d'étudier l'hydrologie avec des résolutions 10 fois supérieures à ce qui se fait aujourd'hui. Donc CARIN qui veut dire radar interférométre en bande KA, c'est donc l'instrument qui va permettre de faire les mesures d'eau sur les surfaces terrestres. Et donc c'est une coopération, comme j'ai dit, franco-américaine entre l'agence spatiale CNES et l'agence spatiale américaine NASA, avec deux industriels majoritaires qui sont Thales Alenia Space pour côté français et JPL côté américain. En fait, Thales Alenia Space est le leader mondial des missions opérationnelles en océanographie et l'instrument fourni dans le cadre de la charge utile océanographique, comme l'altimètre Poséidon. L'impact de la mission SWOT, de risques hydrologiques, les inondations, les sécheresses, la gestion de l'eau en fait, et la compréhension du cycle de l'eau, c'est vraiment la mission au service de tous.
Lunar Gateway is one of the steps for the return to the Moon. For the Lunar Gateway, we are actually the key player in Europe. For the European Space Agency, we are doing the International Habitation Model and the ESPRIT module. We do as well the first habitable model of the Gateway, which is HALO, developed by NASA, supplying the structure of the pressurized element, but many stuff of this structure. And Thales Linearspace is also part of an industrial team competing for the human landing system in US. Much more will come because will need mobility, you will need the communication navigation system. We just won a contract with the European Space Agency for an infrastructure to extract oxygen from the regolith.
The gateway will offer new opportunities for performing science on orbit. This is, I think, is essential also in preparation to Mars, to see how we can face this long-duration mission. A new infrastructure around the moon, I think that will stimulate the young generation to enter in the exploration adventure.
A lunar gateway will be the new frontier for the humankind on space. The frontier is the universe. We expect as well a lot of return for the benefit of the life on Earth.
Now, our second film takes a look at the work of the Australian Space Agency. This year saw the launch of a NASA satellite on Australian soil, which marked the nation as a new option for launch. This film explains more.
The recent NASA launches from the Northern Territory were a historic moment for Australia and saw us return to being a space launching nation. There was incredible excitement around this launch, not just on site, but around the nation. The energy Australia had to know it was starting to launch things into space again was just exhilarating. It was a really important moment to show Australia is open for launch. We have a regulatory framework that's been fully activated. This was the first time NASA had launched commercial rockets from a commercial spaceport outside the United States. The Australian Space Agency played a critical role in achieving this launch campaign. We worked very closely with Equatorial Launch Australia, the operator of the site, as well as NASA to ensure they had the necessary regulatory approvals, environmental approvals and safety approvals to conduct a safe and productive launch campaign. The reaction afterwards, for me, was very heartwarming to hear the younger people who are among the world's oldest astronomers realise that they had contributed to launching a rocket to space from their land. It was really a sign that they could do anything. Launch is the only thing that can open up the full value chain of activities. By having launch in Australia, we'll have an opportunity to work on interplanetary missions, be able to launch satellites when we need as a nation, but also demonstrate a lot of economic return. Here in Australia, we're proud to have a heritage in space, but really, if you look at the technologies you use every day, we're kind of exposed. We use a lot of technology from overseas partners. We're at a moment in time we need to contribute that data, that technology. Access to space is one of the priority areas in our civil space strategy. In Australia, we have significant challenges around climate change, disaster resiliency. Space technologies are pivotal in our fight. So by having the ability to launch rockets here in Australian space, we can launch the payloads we need that can look at our particular needs. By attracting launch, we attract inbound investment, we develop regionally, and if you look around the world, spaceport's often a hub of economic activity. Australia is viewed very desirably as a launch sector, and we know that because of the incredible amount of inbound interest to develop spaceports and consider Australia as an alternative place to launch rockets. As ranges around the world start to get fully booked up. Our local Space Launch and Returns Act is fully activated, so we can license a spaceport and we can permit rockets that go into space. It's demonstrated we have the systems, the processes, the way to work with the traditional custodians in order to do these activities. What we offer the international community obviously is our geography. We can access various orbits. We have long coastlines, unpopulated areas. We have an incredible talent base, we have a responsible regulatory framework, and we can also be trusted. We're an alliance in many partnerships, and this means we can be trusted to look after sensitive technologies like rocket technology. We're fortunate to have some innovative companies here in Australia that are really going after this launch opportunity. In South Australia, we have Southern Launch, who are developing the Orbital Launch Complex at Whalers Way. Going to the north of our nation, we have Equatorial Launch Australia, who run the Arnhem Space Centre. Go out to Queensland, we have Gilmore Space Technologies, and Gilmore is a sovereign rocket development company that's developing an Australian rocket that intends to launch vehicles and people eventually, they say, to all kinds of orbits.
Also in Queensland, we have Black Sky Aerospace, who in 2022 were recognised as the Space Launch Business of the Year. They have been producing rocket fuel right here in Australia and operate a 3 million acre private launch range in outback Queensland.
Around the nation, we're seeing a proliferation of proposals and considerations around spaceports. In order for Australian technologies to be incorporated into international supply chains, you need what's called space heritage, getting them time in the vacuum, the harsh environment of space. And by launching rockets and more ways frequently into space, we can really accelerate that technology development path for Australian companies and Australian payloads. So adjacent industries will contribute to space, but will also benefit from space. In our resources sector, we lead the world in remote operations. We run a quarter of the Pilbara region from Perth, operating trains and dump trucks and drilling things autonomously with humans. Similarly, for many years, we've looked after our teams down in Antarctica. Remote medicine in Antarctica is how you do remote medicine in space. I think it's incredibly exciting to think of a launch-capable Australia in the future, a nation that has returned to its roots as a space launch nation. Not only will we be able to launch rockets, we'll be able to build them, we'll be able to send satellites and payloads, and who knows, maybe people into space one day from Australia in order to do important things that enable us to look after our planet, look after our people, and also partner with regional neighbours. Once we have that capability, we can look further. We can look at missions to the moon and beyond, which can build on some of our great strengths in planetary science, but also inspiring the nation on what it can do.
At Carleton University, the Centre for Self-Replication Research is aiming to make space exploration more affordable and sustainable by developing machines that can duplicate themselves using resources harvested from the moon.
Climate change is probably one of the biggest, most important and most pervasive problem that the human race currently faces. I think that space engineers can contribute. Here at the Centre for Self-Replication Research we're focused on trying to develop a new approach to solving global problems, large-scale problems. Self-replication, the concept behind it is that we can build a single machine which can then replicate itself to build exponentially its productive capacity. One of the current problems we have is the amount of carbon in the Earth's atmosphere. Potentially through self-replication technology, we could perhaps build a machine and get it to replicate itself and suck out carbon out of the Earth's atmosphere. Potentially it gives us this opportunity, this ability to indulge in petascale global projects that currently we can only dream of. It's also important that we project the philosophy of sustainability as we progress out into space. We don't want to bring all our bad habits with us. As a species, we've already outgrown the capacity of our Earth to support us. And we need to go out into space to bring in energy to Earth, to give nature a bit of a helping hand. Our energy needs will continue to grow. No matter how many techniques of efficiency or anything that we introduce, there are always going to be new applications for us to indulge in, for us to consume energy, and our capacity for consuming energy is almost infinite. Working on self-replicating machines involves a whole suite of engineering technologies, ranging from manufacturing to mining to chemical processing to manufacturing, 3D printing. So I have students working on manufacturing, chemical processing, for example. I also have students working in AI, robotics.
I think one of the major advantages of working at the center here is that we are constantly looking at our research almost on a holistic level. I have my part of research, which is extracting the alumina and silica from the lunar soil, but this is also part of a greater research endeavor that the center is undertaking, which is self-replicating machines. So in that optics, we're constantly thinking, how will this be affected by the previous step and how will it affect the next step?
My work at the Center for Self-Replication Research is geared towards the detection of resources that could then be used and processed into a machine. I've created a standoff Raman spectrometer and a contact-based Raman spectrometer. It's an instrument that uses Rayleigh scattering to identify and quantify a solid compound. I love the idea of being able to develop technology, however niche, that will benefit us in the sense of leading us towards greater scientific knowledge.
Performing chemical reactions in space is difficult because you have to consider the physical state of those reagents and also the reactivity of those reagents. You have to take in account how or what reagents are you using, and then you also have to consider what products are you getting. We are going through the process of electrochemically transforming minerals into metals, and we transform those metals into functional parts for the self-replicating machine.
On the face value, it's not a novel process. It's been done now for well over a century. What is novel and challenging in this process is that we're trying to contextualize it to outer space.
Space manipulators that are currently being deployed in space, they are not adaptive and compliant enough for debris removal and reuse of such debris, and how to make them to reproduce new materials from the salvage. The problem we are trying to solve at the center is how to possibly emulate human cerebellum such that we can replicate that in the approach of making robotic manipulators more compliant, adaptive to different tasks. The opportunity to work in space robotics in conjunction with artificial intelligence, I believe it's a rare privilege. Being able to accomplish that, to me, it's very remarkable.
The technologies that we're developing to go to the moon are things that we're going to be able to bring back here on Earth and help the world as a whole, so that we can build global energy networks through space, so that we can develop better industrial processes that are more sustainable not only in space, but here on Earth.
It's just a whole suite of things that are involved in this, and much of it nobody's ever tried to do before, so it's very new and it's very exciting, and there are a lot of question marks, and well, that's our job, you know, as engineers, to do things that nobody's ever tried to do before.
From astronomy to mission design, and from advanced satellite operations to autonomous remote space exploration, artificial intelligence, or AI, has the potential to disrupt how the space industry functions. Let's look at how AI is transforming the sector.
So the Next Generation Plenary is a really wonderful and great opportunity for students and young professionals, because during the IAC there are lots of different plenaries, there are lots of different activities, and of course no one is able to follow them all, and because of that the Federation decided to give a dedicated platform, a dedicated session, a full plenary only for students and young professionals. And this is an extremely unique opportunity, because we are the future. We are the ones deciding what is going to happen in space in the next 30 to 40 years. And so because of that, there is a specific committee within the Federation, composed by students and young professionals, that every year decide different topics that they want to talk about. And because of that, then these topics are presented at the leadership of the Federation. Then the topic is decided, and the Federation every year dedicates this session only for them. And because of that, there is a panel full of students and young professionals talking about the future of space. And I still think, and I really believe that this should continue in the future, because again, we are going to be the future, and it's important to make sure that we also have our voice heard in a so important Congress like this. There are lots of opportunities for the next generation within the IAF. Just to give you some numbers, this year in Paris we have 45% of the attendance that are below 45. So this means that half of them are here because they really want to build the future of space. And so most of them, maybe they're not aware what are all the opportunities, and there are plenty, because every year the Federation provides different awards and scholarships that are called Emerging Space Leaders and Young Space Leaders, and these are awards and recognition to recognize excellent students and young professionals that are part of our community. And I really encourage, the students and professionals to take a look at the website and see, these specific opportunities, because the Federation provides, for example, 35 scholarships for students and young professionals to come here and attend the Congress thanks to this scholarship given by the Federation. But not only, the Federation is also composed by different committees. And there are committees that are only specific for students and young professionals. And it's not so complicated to be part of them. You can become a member and contribute to the Federation and give, again, the voice for students and young professionals and be part of the future, not only of space, but also the future of the Federation.
I'm now joined by Dave Morrow, who is the Business Development Lead at Lockheed Martin. Thank you very much for joining us.
My pleasure.
So why don't you talk us through what role Lockheed Martin is playing in space exploration right now?
Okay, well, so Lockheed Martin starts at the edge of the universe. We have been exploring space for many years, and so one of the things we're most proud of is the NIRCam camera on James Webb Space Telescope, looking out to 13.6 billion years ago. Now we reel that in, and we're also playing a really nice role in planetary exploration. So the universe and galaxies, and in our solar system, we're currently flying 8 missions. So we're flying a mission at Jupiter right now called Juno. We're flying an entire series of communication satellites at Mars, and we're busy developing a spacecraft to go to Titan, a moon of Saturn, and a couple of spacecraft, 2 of them, to go to Venus to map the surface of Venus. And then, even closer to home, we're working on the moon. Everybody loves the moon. So we've got a small robotic spacecraft that's going to launch next year that will map where all the water is. Water is the key to life. Water is the key to much of our exploration on the moon. So we'll map where the water is. And then, of course, astronauts. Lockheed builds the only deep space rated crew transportation system, Orion. And so Orion will ferry astronauts to and from the moon for the next, we think, maybe 10, 20 years. So Lockheed Martin has a huge role in that. And once we get to the moon, we're going to build a rover to drive folks around. We're going to build a communication satellite called Parsec to send all the data back. So the universe is ours. We start at the edge and we move in all the way to the moon.
That sounds absolutely incredible. So what are some of the main focuses right now?
Well, like I said, lunar mobility is a really big deal for us. So we've teamed up with General Motors to invest in building a lunar mobility system that will drive around with astronauts for a couple of weeks a year when the astronauts are there, but also has autonomy. So when the astronauts come home, that rover could drive around and do scientific missions for the rest of the year. It's a wonderful project, and the fact that Lockheed Martin is investing in and building the hardware is really going to help NASA and ESA move into a services-based economy. We want to stay at the moon this time, and the way we stay at the moon is if there's people making money and sustaining a lunar program. So lunar mobility, lunar communications, big deal for us at the moon.
And what are you most excited about for the future of space exploration, and what sort of role do you see Lockheed playing in that?
Well, I think the most exciting thing for me now is that we're really moving into an era where there's many, many more players in space. We went to the moon in 1969. We went to the moon back then, but we came home because it was all based on just government go and government come back. Once we have the private sector involved, once we have more people involved, we're going to stay. So part of that is enabled by the new generation. We have so many young people ready to move into space. And let me just tell you, the young people are so talented, smarter than my generation, standing on our shoulders with new tools and new capabilities and a new economy to be able to really stay at the moon this time. And then of course, once we're at the moon with people, we can start thinking about the moon and Mars. We can take what we've done with robotic exploration at Mars and the rest of the solar system, and we can take humans there. So we have concepts to take humans to Mars by the end of the 2030s. That would really be awesome for us to be a multi-planet species, Moon and Mars with human exploration.
Oh, it certainly would. Dave Morrow, thank you very much for your time.
My pleasure.
Thank you so much for watching. That's all for the second episode of IAF Congress TV. But remember, we'll be back each day of the Congress with a new episode highlighting all that you need to know from the 2022 IAC. We look forward to seeing you tomorrow.